In our yesterday lesson, we introduced the binomial theorem. So let me just write it down kuti tione kuti tikuirangarira here. Takati binomial theorem ine two forms dzainonyorwa nayo. Chekutanga tiri kuexpanda an expression with two terms. That's why ichinzi binomial. In our yesterday lesson takaexplaina kuti bi zvinongoreva kuti two. Saka binomial theorem applies kana tichida kuexpanda an expression with two terms. In our case, a na b zvakaconnectwa this arithmetic operator plus. So this is a plus b to the n. Yatakati tinogona kuinyora nenzira e, inogona kunyorwa so tiri kuti n choose 0 tobva tati a to the power n minus 0 multiplying b to the power 0 like that. Tobva tati plus n choose 1 a to the n minus 1 multiplying b to the 1 plus n choose 2 tobva tati a to the n minus 2 multiplying b to the 2. Zivai zvakare kuti amwe mabhuku anenge akainyora yakadai so a plus b to the n is equal to vanoti n choose 0 like this. Yobva yazoti chi a to the n minus 0 multiplying b to the 0 plus n choose 1 a to the n minus 1 multiplying b to the 1 and so forth. But kana tichida kuinyora, especially kana tichida kuinyora iri more simply put, tinongodai so a plus b to the n is equal to n choose 0 yonyorwa yakadai so a to the n minus 0 multiplying b to the 0 plus n choose 1 a to the n minus 1 multiplying b to the 1 plus n choose 2 a to the n minus 2 multiplying b squared and so forth like that. So that is the binomial theorem. In today's lesson toda kuintroduce inonzi a universal expansion theorem. Saka chatoda kudzidza panapa manje ndechekuti universal expansion theorem iri necessary zvayo. So it's universal expansion theorem. But kana kuri kuti muruda kusarudza kuti moshandisa ipi kana ma conditions achi satisfyiwa, I would just encourage kuti mushandise the binomial theorem. So this is what is called the universal expansion theorem. So we should know the conditions under which the binomial theorem applies, and my conditions acho tikada kuma summarize. Firstly, we should have two terms, and this is condition number 1. But our condition number 2, n should be greater than 0. And also for our condition number 3, n should be a whole number, element of whole numbers. Saka n should be a positive whole number. Correct, n cannot be fractional. Hatikwanisi kuisa a plus b to the power half, for example. N should be a positive whole number, and we also should have two terms. Kana takuda apply the universal expansion theorem, maybe rekanditange ndainyora pasi, because zviri kunzi necourse reader, students are encouraged to master the universal expansion theorem that applies to all values of n. Saka the added advantage panapa ndeyekuti it applies to all values of n. Mapaona. And this is of utmost importance, all values. Binomial theorem is limited in the case of n, which is the power or the exponent. The power in binomial theorem should be a positive whole number. but kuri kuti hatina kupiwa, maybe tapiwa a fraction for a power, like example yandambopa kuti to the power half, we cannot use the binomial theorem. Maybe tapiwa a negative power, we cannot use the binomial theorem. Maybe tapiwa a mixed number as a power, you cannot use the binomial theorem. So in cases where n is not a positive whole number, we have to use this universal expansion theorem. Inoti kudini? Inoti 1 plus, let me write it in white. Inoti 1 plus x to the power n, like this, is equal to 1 plus nx over 1 factorial plus n minus 1 x squared over 2 factorial plus n minus 1 n minus 2 x cubed over 3 factorial and so forth. So I want you to pause, mutarise relationship irapo. Like, these are not as much counterintuitive. Mukatarisisa that theorem, you can actually take note of a relationship. Then to kuti munyore pasi what you think is going to be the next term after that fourth term. Then manyora pasi, then moita and pause to batsrana. Saka the next term panapa ingerichi n minus 1, n minus 2, n minus 3, x to the 4 over 4 factorial. Let us just put a bonus plus n minus 1, n minus 2, n minus 3, n minus 4, then x to the power 5 over 5 factorial. This is the universal expansion theorem. Saka universality yacho ndeye kuti munogona ngoziva iyi chete, mototadza kuziva binomial. Ino apply any and everywhere. But binomial manje, it's special in how it makes things simple. Saka I would equally encourage kuti mubate futi binomial. So panapa takuda kuchitarisa ma conditions of applying this universal expansion theorem, which are very important. Saka conditions for applying universal expansion theorem. Let me just shorten it to UET. What are these conditions? Condition number 1. The formula only works when the first term is a positive 1. Saka, the first term should be 1, should be a positive 1. The shorten out positive 1. As you can see, panapa irutangana na 1 plus x to the n. So that's the first condition. So if the first term is not 1, what do? We factor out the limiting term. Chakuratidza tutozita say toshandisa factorization. Then you should also remember, as a nota bene, I also remind you to pull out the power as well when factoring out the term. Saka tineka exercise katoda kuita panapa. Toda tanga method 1 tichishandisa binomial theorem, and then tichada kuita a method number 2 tichishandisa universal theorem. Universal theorem, but in full it's universal expansion theorem, like this. In both cases, we want to expand to 3 terms. And toda ku expand to 3 terms. So let me write pakati panapa. We want to expand to 3 terms minus x minus 2 plus x to the power 4. Okay, satinotanga nebinomial theorem. Binomial theorem inoaplya here paquestion yedu. What's your answer? If it's yes, you are correct, because we have two terms, -2 na x. We also have a positive power, which is a whole number, and over 4. Saka we can apply it. But pakuiaplya manje, as we have already known, ngatitange tanyora general outlay a plus b to the n, and tongonyora two terms just to remind ourselves. Saka it's n choose 0 like this, and so panapa ndoda kuti pave ne line richa separate maworkings edu. Okay, saka patiri kuti chi n choose 0 todati a to the chi n minus 0 multiplying b to the 0 togona kuti plus n choose 1 todati chi a to the n minus 1 multiplying b to the 1 plus and so forth. Okay, takatarisa question yedu, we can easily see kuti a are equal to -2 because it's a plus b to the power n. Panapa it's -2 plus x to the 4. b wedu anga are equal to x and n wedu are equal to chi to 4. Saka chakungodikwa apa manje, remember first 3 terms. Saka chakudikwa panapa yangu wa substitution. Takuti -2 plus x to the 4 is equal to tonyora our first term, n choose 0, n di 4, so it's 4 choose 0. A wedu ndi -2, so it becomes -2 panapa to the power 4 minus 0 multiplying b ndi x to the power 0. That's our first term. Tova tati plus our second term inenge ichiti 4 choose 1 minus 2 to the power 4 minus 1 multiplying x to the power 1. Then our third term plus 4 choose 2 apa irukuti -2 to the power chi 4 minus 3 multiplying x squared. Ndosa inenge ichita kudai so. Sangatirambe chidzika nayo anditi. Okay, saka tichidzika nayo kudaro, panapa tikaenda ku calculator kwedu kuti tino simplifier, this is going to be equal to, in our calculator tichatanga nekuda kuziva kuti 4 choose 0 ndiani. Toona kuti 4 choose 0 ndi 1. Saka panapa for our first term tiri kuti chi 1, uyu ndi 1 kawo handiti. Saka tiri kuti ngatigweza bracket 1 towatati times panapa ndi 4 minus 0 which is 4 minus 2 to the power 4. 2 times 2 ndi 4, 4 times 2 8, 8 times 2 ndi 16. So 2 times 2 ndi 4, 4 times 2 ndi 8, 8 times 2 ndi 16. Kurati panapa we are going to be multiplying with 16. Then x to the power 0 panapa we know kuti ndi 1. Any number raised to the 0 ndi 1. Saka inongobuda iri 1 times 16 times 1. This is our first term. Towatati plus. For our second term, what about 4 choose 1? What do we get out of it? Saka 4 choose 1 ndi 4. Kurati panapa tina 4. Then we are going to multiply with 4 minus 3 ndi 1. Alright, I'm sorry, nanda kuita mistake. Tripa second term andiri. Saka tati 4 choose 1 tikaona kuti ndi 4. Then panapa tichati 4 minus 1. 4 minus 1 ndi 3. Saka minus 2 to the power 3. And inenge iri negative answer. 2 times 2 ndi 4. 4 times 2 ndi 8. So it's negative 8 panapa. But irikuti times x to the power 1 which is times x like this. So let me verify my things. Panapa tati 4 choose 0 minus 2 to the power chi 4 minus 0 times x to the power 0. Panapa tikati 4 choose 1 minus 2 4 to the power 4 minus 1 times x to the 1. Panapa tikati 4 choose 2 minus 2 to the power 4 minus 2 ndasananyadza kuibudisa zvakanaka panapa times x squared. Okay, so panapa takuchisa our third term. What is 4 choose 2? 4 choose 2 ndi 6, so it's 6 times, then panapa 4 minus 2 ndi 2, kureva kuti minus 2 squared inongodzoka iri chi 4, multiplying x squared like that. Saka in eventuality panapa tiri kuti 1 times 16 times 1, which is 16, then panapa it's going to be a negative answer. Takuchiti 8 times 4 ndi 32, sakapo it's minus 32x, then panapo it's a positive answer. 6, 12, 18, 24, so it's plus 24x squared. That is the answer we are getting out of expanding using the binomial theorem. Anditika. Okay, saka taona answer yatawana tichazoikombea yedu. Takuda kuziva kuti ko tikashandisa the universal theorem. Satuda kushandisa universal theorem kukompyuta chi minus 2 plus x to the power 4. But tinoziva kuti universal theorem sekuinyora kwataita pamusoro inoti 1 plus x to the power n. Kureva kuti pana apa panofange paina 1. Because of that, we have to factor out minus 2. Kuitira kuti apo pave na 1. But tika factor out minus 2, icha factor this x, kuroti ngeya plus chi x over minus 2, like this. Inoramba iri to the power 4, and pata factor out minus 2, tanga chifanga kubuditsa to the power 4 zvakare, like that. So that's how we simplify it. Minus 2 plus x to the power 4. We factor out minus 2, but patino factor out minus 2 inobuda ine power, correct? Tino factor out minus 2 to the power 4. Yobva ya factor the first term kutive 1, you factor the second term ichiva x over minus 2. This is basic factorization yangowedzerwa zvishoma. If you find this part difficult, please notify me in the comments. Saka further simplifying that, this will be equal to, we can actually solve minus 2 to the power 4. It turns out it's going to be positive because an even power, you need to nullify the negative sign. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Saka pana pengerichi 16 like this. Then todai you have 1. X dividing negative 2 yakafanana nekuti minus x over 2. And this is to the 4 like that. Saka tai simplify kuti ikwanise ku apply chi what we want to learn. Now we know kuti maybe I have to repeat it. 1 plus x to the power chi n. 31 plus x to the power n iri equal to chi, iri equal to 1 plus nx over 1 factorial plus n minus 1 x squared over 2 factorial and so forth. And it ndo zvatanyora kumsoro kunoku 1 plus. This is I believe my copy in your notes. Zvabuda zvakadaro manje. Kana takuda kuchizva apply panapa teta kudai so. Tenge takuti 16 andika bracket 1 minus x over 2 to the power 4 iri equal to 16 todai so. Remember question yedu iri kuda the first 3 terms. Andika the first 3 terms. Saka kana takuda ku expanda this part iri mu bracket ina 1 minus x over 2 to the power 4 because 16 tatoibuditsa taita factor out. Tengeta kuti chi the first term panapa it's 1 because my terms are not separate kana plus kana minus, which are arithmetic operators. Saka ndi 1 apa tvatati plus anyway dambo richi tatisina kuzispecify. Saka panapa tina 1 and x yedu inge yachi minus x over 2 yachinja and n yedu inge richi 4. Munzisa n yedu ndi 4 because n power. saka panapa for our second term tichiti n4 times x yedu ndiani ndi minus x over 2 like this dividing 1 factorial plus takuisa the last term. So for our last term tikutichi n which is 4 iri kumultiply 3 from 4 minus 1, then x squared it's minus x over 2 squared all over 2 factorial like this. Andika tikadai so manje tenge tarova. Okay, saka this is equal to takuda simplify 16 1 plus panapa 2 into 2 1 into 4 ndi 2 kureva kuti inenge iri minus 2x over 1 factorial. 1 factorial ndi 1 mafactorial mufanga masiva. 1 factorial is equals to 1, 2 factorial is equals to 2 times 1, 3 factorial is 3 times 2 times 1. That is what it means. Saka panapa since yasangana iri 1 plus or minus 2x kuti tisazvinetsa ngati kare tatongo pagadzirisa panapa kuti patongova nani na minus. Saka ndo zvazvinge zvakaita kudai so. Then kana chida kusolva panapa manje tinogona kuzviita hedu tiri pano 4 times 3 4 8 12. Saka panapa inge iri 12 andika minus x squared ndi x squared over 2 squared ndi 4 ama indices atikadzidza kana mchida revise munotiudza. Then toarati 4 into 4 1 4 into 12 4 8 12 ndi 3 kureva kuti panapa pamusoro apa inge iri 3x squared. Ta simplify everything zviri pamusoro saka it's basically plus 3x squared over 2 factorial 2 times 1 ndi 2 like this. Saka takudai so manje kuti tichisvika pa answer we just have to expand. So this is equal to 16 times 1 is 16, 16 times minus 2x ndi minus 32x, and then lastly 2 ino ikapindwa inoita 8 andika 2 into 16 ndi 8, 8 times 3 8 16 24, so it's plus 24x squared. As you can see, this is the same answer. Saka you can use binomial when applicable. You use the universal expansion theorem where it is applicable. So this is the part I wanted to teach you. In our next lesson, teacher shandisa this universal expansion theorem, but tichi apply neku tichita nema partial fractions. So we are going to be partializing. To prepare for our next lesson, you might as well revise the lessons we did on partial fractions so that you just have a basic idea of partializing. You get it? Then after taita this part, which is our next lesson, pachange tichi apply partializing of fractions to the universal expansion theorem, tichaita Pascal's triangle. After Pascal's triangle, tichaita behavior of sequences, which is going to be our last subtopic before we get into practice questions. So keep on working hard. If you have any questions, use the comments. You need extra lessons, use our numbers. Otherwise, thank you and take care.